On today's show, ancient remains on the Australian coastline, a close-up view of eye shapes, and boomerangs that don't come back, all on Hot Science.
Hi, welcome to Hot Science. Thanks for joining us.
Hello.
Now, Sue, are we going to do our hot experiment with this
We sure
sugar?
are. We're going to be burning some sugar, and we're going to do it very, very quickly, because our body is always burning sugar up, the food we eat, but it releases the energy really slowly in lots and lots of reactions. We're going to burn it really quickly.
How?
Right, well, let's start with putting some sugar into this beaker. I'm going to put quite a bit in. I'll just scoop it in, actually. Oh, yeah, okay. About that much will be fine. Just shake that around and set it back down. Now, we're going to burn the sugar with some acid, sulfuric acid.
Right.
This is concentrated, so I'm taking a great deal of care. I add the sugar like, the acid like that, put that down. Give this a stir with the rod.
Ooh, it just looks all gluggy.
Yeah, it does, doesn't it? I need to mix that quite well. Now, already you can see that the sugar has actually changed colour.
It's gone yellow and it's getting darker.
Okay, so it's starting to burn.
Oh, look, it's really dark. Right in the centre.
Now it's getting really dark.
Yeah, it looks like toffee
It
almost.
does, doesn't it? I'm going to put this rod back into here.
Oh, it's almost black.
It's turning black. Now, that's because it's the carbon in the sugar that you can see that is black.
Well, what's sugar made up of?
Well, it's made of carbon, hydrogen and oxygen. And as it's burning with the acid, some things are being given off, and what we'll be left with is that carbon. And this experiment is called the growing black mass experiment. Because
Is that what I should be looking for?
it will start to grow.
Really? And the sugar's all collected together too, hasn't it?
It has. It's sort of caramelising a little bit in the first steps. And it does take a little while, but it will start to happen.
What, start to move?
No. We're very lucky that our bodies don't use reactions or quite like this, that we actually have lots and lots of step-by-step reactions to break down the sugar that we eat. Otherwise,
We turn into that?
well, hey, it's starting to move now. I can see inside the container,
Ooh.
starting to puff up. Here comes
Oh, and there's
some gases.
smoke, yeah?
Now, this gas that you can see coming off, most of that is actually water vapour, which
Like
is
steam?
which is being given off by the chemical
Oh, look,
reaction.
it's coming.
Can you see it growing and growing and growing? Oh, I think it's going to stop right about there. Now, the reason it puffed up and grew black, oh, I'm looking through that smoke, is that, as I said, sugar's made up of carbon, hydrogen and oxygen, and as sugar burns, the hydrogen and the oxygen are given off as water vapour, and some of the carbon is lost as carbon dioxide, but that water vapour and carbon dioxide gas are trying to escape. What we have left is the carbon, and that gets puffed up by those gases.
Pulley.
Pulley? Oh, pulleys are great, aren't they? You can find them in lots of places like lifts and cranes, even in my toys down here.
Hello, Ooze.
Hi, Sue. Hey, Sue, take a look at my pulleys down here.
Oh, pulleys are terrific. You can use them for lifting things up.
Yeah, that's
Can I have a
right.
go with your toys?
Sure.
Okay, so if I use this handle here,
Yeah.
I should be able to lift that weight.
You sure
because
will.
Of the pulleys?
Yep.
Up
There it goes.
and down. And this toy has got 3 pulleys, hasn't it?
Yep.
It's got one at the top here,
Yeah.
one in the middle here,
Yeah.
and one right down at the bottom.
That's
Near the
right.
handle.
Yeah.
And did you know that we can have pulleys, not just one pulley to lift things up, but we could actually have a few pulleys
Right.
all sort of linked together on the same piece of rope. That's called a block and tackle. And by having more than one pulley, it
Yeah.
makes pulling the load much, much, much easier.
Right.
You've got another toy here. Can I have a go at this too?
Sure, go for it.
Oh, so
Yep.
this is a forklift truck.
Yep, that's right.
And,
Up it
now I
goes.
can wind it up
And wind it down. Yeah.
Well, pulleys are used a lot in industry. Let's have a look and see how they are used.
Okay.
This is in a scrapyard. You can see some pulleys. You can see the cables being wound up. Oh, look, there's the pulley in the middle, spinning around with the cables wound around it.
Wow,
So
they're
pulleys,
pretty amazing.
They
aren't
are. We use them in lots of different ways. We
Yeah.
can make a crane that uses a pulley too. Should we
Really?
do that? Yeah.
Yeah, let's do it. It's
Okay, the
great.
equipment's over here, Ooze.
Okay.
What I've got here is a
Yeah.
piece of wood, and in the piece of wood I've driven a nail.
Oh,
There's
yeah.
one here, and I've got a piece of modelling clay stuck on the top of that at the moment. It's a bit hard to see the nail, but there's another nail here at the other end of the piece of wood.
Right.
And a thumbtack And I'll show you what that does a little bit later on.
Okay.
And then I put a cotton reel on one of the nails and a piece of modelling clay to stop it coming off.
Oh, and the string wound around the cotton
That's
wheel.
right.
Oh,
and at the other end of the piece of string, look, Ooze, there's a paper clip. And I've undone the paper clip a little bit so I can use it for hooking and lifting things up.
Oh, right.
So I'll just put a cotton reel on the other nail there like that.
Yeah.
And put the piece of string over the top like that.
Okay.
Now, it looks a little bit like a fishing rod, doesn't it?
A little bit, yeah. We're not going to catch fish, are we?
No, we're going to put this pen cap in the cotton reel.
Yep.
If I can just, I might do it just there.
Okay.
And that's now my handle. So I can go up and down. And the base of the crane is going to be this cardboard box. And if I lift the lid up, like this, I hope I don't hook you with my hook.
Oh, I hope not.
There's a hole in my box and the stick fits in nicely.
Right.
Like that. I can sit it on top.
But
on an
Sue,
angle. What's that?
If we're going to lift a load up, it's going to topple over.
Well, cranes have something called a counterweight, which holds this end down. So I'm going to use a hot science book.
Oh, great.
And I can wind things up. Now, this is going to be the load. I've got a cup that's empty at the moment.
Yeah.
And a piece of string tied to the top. So I can hook the hook over the top.
Yeah.
Just wind up the slack and put a load. Oh! So that part works. Now, for my load, I've got some marbles. Let me see. I'll put in... Whoa, I've lost one.
Yeah.
Oh, lost a few.
Oh,
put in a handful like that. Do you think that's enough?
Yeah, that's plenty. No, actually, a couple more.
Okay.
Heavyweight.
Well, another handful. There we go.
That's great, yeah.
And then I can wind away like this.
Wow.
And when I want to stop winding and hold the load up there, I'll just wind the piece of string around the thumbtack. That's what that was there for. And now look, it stays there and I can move the load around.
Yeah.
And when I want to drop it over here near you, I can unwind it again and let it go down. Why don't you try making a crane like this and try different loads and see how much your crane can lift up?
Meet my cat Einstein. Isn't he beautiful? He's quite happily sleeping on my lap here. Have you ever had a close look at a cat, particularly at its whiskers, like Einstein's here? Whiskers are very important to a cat. Now see the longest whisker on Einstein, I can't quite find it, about there. That whisker is a little bit longer than the widest part of Einstein's body. And that's so Einstein doesn't bump into anything. Oh, waking up a little bit there. So if Einstein was, say, to go into a pipe, he'd know that if his whiskers wouldn't get through, then the rest of his body wouldn't get through. And that's really important so that the cat can stay alive and healthy. Now, we don't have whiskers on our body, but we do have touch-sensitive areas. In fact, they're all over us, like in our fingertips, our lips, even the top of our head. I want you to do something for me. Get your hand and place it on the top of your scalp. Just your fingertips, very, very slowly. What feels first? Is it your fingertips or the top of your scalp? It should be the top of your scalp. But Sue, why is that?
Hello, Bob. Look at Einstein.
Isn't he beautiful?
You mean why can you put your hand up here and feel it first on your scalp before you feel it on your fingertips? Okay. It's because our body is covered in these touch-sensitive areas. It's also covered in hairs. And if we had a look under the skin, just where the hair goes into the skin, we'd find that there are nerve endings there. And it's these nerve endings that actually detect the movement and they send a message to our brain.
And that's a nerve ending?
Yes, there's some nerve endings, and they're scattered all through our skin. They send a message to our brain along other nerves and tell us that we've touched something.
So we don't have nerves in our hair?
No, no nerves in your hair, just in the skin at the base of the hair. And those nerve endings, those touch-sensitive ones, are all over our body.
Well, I've got something for you to think about. Why does it hurt to pull out your hair, but it doesn't hurt when you cut it? Have a think about it.
Next, boomerang business.
Have you ever seen one of these being thrown before? Well, it's a returning boomerang, but not all boomerangs come back. In fact, they come in all different shapes and sizes and have different uses. And we have our very own boomerang expert in with us, Philip Jones. Hi, Philip.
Hello.
Now, we have 3 different types of boomerangs here. Can you tell me about them?
Well, this is a returning boomerang, as you said, but these other 2, this one is a hunting boomerang from Central Australia, and you can see the completely different shape of that one.
And it's bigger too.
Yes, a lot bigger and heavier. This one from Queensland is also a hunting boomerang with the pointy ends.
And what, they were used for killing
For
animals?
Killing animals and birds. Yes.
And also for throwing, like we can see right now. It's pretty old footage. Now we've got some other boomerangs here as well, some rather decorative ones.
Yes, this one is very similar, as you can see, to the Central Australian boomerang that I showed you earlier, but this one has a hook on it.
Ah, yes, right here.
Yeah. This was used for throwing into flocks of birds, and you'd generally get one or two. It was also used for hunting and fighting, and it could be thrown against an opponent who had a shield, and it could hook around the shield.
Right, and then hit them in the head.
Yeah.
Oh,
possibly.
yuck!
This is about 100 years old.
Right, and what about some of those smaller ones?
Well, we've got an example of a highly decorated one with a sort of swollen head, I guess, which comes from New South Wales, and these are traditional designs, probably of the Darling River area in New South Wales. This example just shows how Aboriginal people have adapted to European art and started incorporating those symbols and patterns and shapes and animals and so on onto them. This one is a further example with animal tracks. You can see the little wallaby track along here.
Right, and little people? Human ones?
Yes, there.
Right.
And perhaps possum tracks just there.
And
this one again is an example of some of the largest boomerangs in Central Australia, which come from the Lake Eyre region. These are designs from the Cooper Creek or the Darling River. And
it's huge. Why is it so big?
Well, these were sometimes used as clubs, that is, they weren't thrown. They're boomerang shaped, but they were just used for fighting, yeah.
Oh, good. I don't think I'd like to meet one of these. Now, boomerangs have taken off, haven't they? Like they show us some Australian culture?
Well, they have, and it's become a symbol of Australia. This is taking us back to the 1950s. Classic example of an ashtray using the boomerang motif. You have salad bowls.
Oh,
There's
dear.
a nice
Isn't that
example
attractive?
of that. Yes. But it's still with us today, and it's also spread into sport. People have formed clubs. There are clubs in America and Germany.
What, for the returning ones, I hope?
Yeah.
Not for the clubbing ones?
No, for competitions, basically. And they take them to obscure and bizarre, out-of-the-way places. This one was thrown around the South Pole. It's in its special little carrying case.
This is
here.
a boomerang carrying case, is it?
Yes, that is, yeah. And that one was thrown around the South Pole in 1987 and went through 24 time zones.
And then still came back?
Yes. Yes.
Excellent. Now, that is a tennis racket, isn't it?
Well, it looks like a tennis racket. I wouldn't really play tennis with it, but it is in fact a returning boomerang. It has the same aerodynamic qualities as a boomerang, a returning boomerang. And this is the world's first returning tennis racket.
Isn't that amazing? Well, Philip, thank you so much for coming in.
Pleasure.
And as you can see, there is more to boomerangs than just whether they come back.
In some countries, ice cream is made from coconut and peanut oils. It's also rich in vitamin A. Vitamin A is also in carrots.
Hey, Ooze.
Yeah?
You've got two eyes like me.
Yeah, of
And
course
they're
I
pointing
have.
in the same direction, which
Yeah.
means you'd have stereoscopic vision like me.
That's right.
Stereoscopic vision is what we use to judge how far away something is.
That's
because
right,
our eyes point in the same direction, we can do that. But some animals have got eyes on the side of their head pointing out that way, which means they're looking at different things at the same time and they can't judge how far away something is. So when we look at something like my finger here, have a look at my finger.
Right.
One eye looks from one side, one looks from the other, and both eyes send a message back to our brain of that slightly different view.
Yeah.
And our brain knows how far away something is because of the messages coming from two eyes.
Hey, so I've
What's
got a
that?
trick for you
Yeah.
then. Hey, grab that pen that you got there.
This one, yeah.
Now take the lid off of it.
Right, like that.
Right, yeah. Now I want you to close one eye.
Oh, like that?
No, not that one, the other one.
Oh,
That's
that-
better. Now what I want you to do is hold the pen and the lid up in front of your face.
Okay, like this?
Yeah. Now try and close the lid on the pen again.
Oh, okay, I'll just
It's
line
not
it up.
easy.
Hey, look, I missed completely.
Yes.
That looks so simple.
Yeah, try it with your eyes open. Now.
Okay, line them up again,
Yep.
and
Easy, see?
so if I use two eyes, it's really easy to judge how far away those two things were.
That's right.
Look, not all animals have got eyes like ours, though. Let's join Rob Morrison and find out a bit more.
Like many of the animals in this zoo, I'm a daytime animal, so when my eye opens and closes to let more or less light in, it does so with a circular pupil. But the animals that do their business at night, whether they go hunting or get hunted, have to have more light than that, and they have a pupil which is a slit pupil. It opens up to let more light in. And some of them have pupils that are upright, and some have pupils that are across or horizontal. What's the difference? Well, by and large, the hunters, like snakes and crocodiles, have upright pupils. They work like that. They seem to be especially good when you're running after something or when you're pouncing on something, up and down movements. But the animals that are hunted, like sheep and goats, have to see all the way around them because that's where danger comes from. And so they have a pupil which runs across the eye or horizontally. It's especially good, apparently, for picking up the movements of things coming in on the same sort of level as they are.
Thanks, Rob. Now, Sue, I have a question for you.
What's that?
How steady is your hand?
Oh, look, it's very steady.
No, put both of them out like this.
Like that?
Hold them still.
Oh,
Look, they're shaking.
shake them.
Well, I've got something that we can test out your hand movement and whether you are really steady.
great.
I call it a shaker. Now, I used to use these heaps when I was at school. They're really easy to make. You just get some modelling clay like this with 2 lid containers. Place the modelling clay in and around there. Then get a fairly thick piece of wire and make sure you put heaps of loops in it like I have.
Oh, that makes it tricky.
Yeah, very tricky.
okay.
I'll show you how in a minute. Then place those in the modelling clay like that so it stands up.
Right.
Then you have to make a simple circuit. Put wire here into a battery, another wire from the battery to a light here, and then a third wire from the light.
All right, all the way back to the wire at the
Right,
start.
yes, and then when you've got it up like this, you hook it round and there you have your shaker. Now I've already made a model just for you to test.
Now, hang on. Let me just think. So the final wire is
Well, I'll
actually
show you.
connected.
I'll show
Okay,
you. I'll show
all
you.
right.
You're always testing me out. This is your turn, okay?
Okay, so we haven't got a circuit yet.
Well, we will.
All right,
We will. Okay, I'll show you where the circuit is. As soon as I connect that wire like that,
Ah, okay.
there's our circuit.
Fine.
Now that is the trick.
Right.
You have got
easy.
to be able to put this around without touching the main wire. See like that?
Okay. So this is like the detector.
Yeah,
Tells you. Oh,
that's right. Now I'm going to make it even harder.
Why?
Because
I
I'm not
can
going to
do
let you do. No, I'm not going to let you do it with both eyes. I want you to do this with one eye.
Oh, okay.
Okay?
Sounds easy.
Close your
So,
eye.
like that?
Yep.
I have to put it on? Oh, look, I can't
No,
even. There we go.
there goes your eye shut.
Hey, that's How am I going?
Have you got an eye closed?
Yeah. Look.
Oh, hang on. There you go.
No, it's true. How am I going? I can't see the light bulb. Is it?
Yeah.
Oh, it's look. It was on all the time.
Completely.
Can I
Do
try
it
it with
again,
2?
yes.
I'll try it with 2 eyes this time and see if I do any better. Hey.
Yeah,
Oh,
now shut your eye.
okay. Shut. How am I going now? I can't see the
Yeah,
light bulb.
no, you've got way off the mark.
It's really hard to do when you've only got one eye.
It is pretty hard
So
to
it's
do.
back to stereoscopic vision.
That's right, that's right. Now, why don't you make one of these at home and test how steady your hand is?
Hope it's as steady as mine.
Graffiti won't be a problem anymore with this unbreakable vandal zapper.
What a great machine! No more vandals, yay! I'm really good at building things. What about you? Hey, take a look at this. Do you think you could build one of these? Look closely now.
Next, treasures from the earth.
These people are digging up the past. They're paleontologists, scientists who study fossils to learn more about prehistoric times. They're trying to discover how Australia might have looked millions of years ago. And here at Inverloch in southeastern Victoria, there are plenty of clues.
Today, the sea washes up onto this shore platform. 120 million years ago, it was very different. The sea was hundreds of kilometres south of here, and this area was a vast floodplain crossed by streams and rivers. There were trees growing on the banks of the rivers, and we know that because we found their fossilised remains embedded here in the rock. And we also know that there were small dinosaurs running around this area. And the reason we know that is we are finding their fossilised remains also in this rock. And some of the most exciting finds that we have discovered in the last 2 weeks are the teeth of these little animals. We have teeth of small meat-eating dinosaurs which stood about 1 metre high. We also find the bones of small plant-eating dinosaurs called Hypsilophodont, which means high-crowned tooth. And these dinosaurs were the most common dinosaurs found in Victoria. And the most important part are the teeth. And the teeth tell us exactly which type of dinosaurs they were. And the teeth that we find are embedded in the rock, but it will maybe months before we actually get to remove them from the rock and find out exactly what species of dinosaur they were. Here we've just uncovered another Hypsilophodont tooth, and we know that it is Hypsilophodont because of the ridges, the high-crowned ridges on the crown. At this particular site, we are actually restricted in our digging time. We can only dig for about 3 hours either side of low tide. And as soon as the tide starts to come in, we have to pull out because the whole area is then covered by water. We come back the next day and the area that we've been digging in has been filled in with sand, and it's like starting anew every day. The significance of the dinosaurs from this area is that Australia 120 million years ago was much further south than it is today. It was in fact joined onto Antarctica and was about 75 degrees south, which put it within the polar circle. So these little dinosaurs were living at a time where Australia was in darkness for 3 to 4 months of the year in the polar winter. So these little animals were able to adapt to living in darkness for 3 to 4 months of the year, which makes them unique in the dinosaur world. The most exciting thing to us is that every rock that we crack open has the potential to contain a bone from an entirely new species of dinosaur that has yet to be discovered here in Australia.
This project is being carried out in conjunction with the Museum of Victoria, and it's been going on now for about the past 15 years. The paleontologists are slowly piecing together their picture of a very different Australia.
It's quiz time!
Red.
Hey, Ooze,
Yeah?
why do cats have whiskers?
Oh, that's an easy one, Rob. That's so they can sense things.
That's right.
Hey, Sue, I've got one for you.
Yeah?
What sort of vision do I have?
Oh, well, you've got 2 eyes and they're pointing
Yeah.
in the same direction, so
Yeah.
you'd have stereoscopic vision.
That's right. You had a bit of trouble with stereoscopic vision before, didn't
I did,
you?
didn't I?
It
Yeah.
depends. Now, Ooze, you haven't done any formal introductions.
With who?
Who's this dinosaur here?
That's Plasiosaurus.
That's your favourite dinosaur, is
Yep,
it?
sure is.
Do you want to meet mine?
Yeah.
We have Brachiosaurus here
Right.
and Triceratops here.
Oh, great. Maybe we should have a dinosaur party a bit later.
We could do that. And if you want an investigation to try, why don't you try making a model crane like ours
Yeah.
and trying out different loads and see how heavy a load you can lift.
Can we try Triceratops in
Oh,
there?
sure.
Yeah.
Give him a
Excuse me,
lift.
Ooze. There we go.
Are you ready? Here we go. Up.
Up he goes.
We have to go. We'll see you next time.
Yeah, bye-bye.
Bye.
Bye.